This is Module 6, Lesson 2. Read the objective out loud while I read it. I can construct a coordinate system on a plane. So fluency practice. We're going to spend about 10 minutes on fluency. Then we have a few minutes on our application problem before we move into our concept development. So let's start out by counting equivalent fractions. So this is Fluency Activity Reviews Lesson 1 and prepares you for today's lesson. So let's read these. I know they're difficult to read, so I highlighted them. 0 fourths, 1 fourth, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths, 8 fourths, 9 fourths, 10 fourths. Now, let's read it again, but let's replace the fractions with whole numbers when our fraction turns into a whole number. So 0, 1 fourth, 2 fourths, 3 fourths, 1. 5 fourths, 6 fourths, 7 fourths, 2. 9 fourths, 10 fourths, 11 fourths, 12 fourths would be what? 3. All right, now, next part is find the missing number on the number line. So I'm going to go ahead and let you first find out first where the origin is, and then find how does the number line increase? What is the rate or distance of increase? Label it, and then circle and label each one of the letters. Go ahead and check on back. Okay, so hopefully you were able to figure out what the missing numbers were. So this top number line, it increases, the rate of increase is multiplying by 10. So 10 times 6 is 6 times 1 is 6, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6, 6 times 7, 6 times 8, 6 times 9, 6 times 10. So starting at 6, and each time it multiplies by 2, 3, 4, 5, 6, 7, 8, 9, 10. So increasing, it's partitioned into 10 intervals. All right, so the rule is multiply by 10. Well, it's multiply 6 times 1, 6 times 2, 6 times 3. Then we have the rate of increase here, where on this number line, it increases by sixths. So it increases 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. Then this one right here, it increases by 1/3. So it's 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3. 9/3 is 3. I guess this is a rate of increase. We should say 6 here. 6 times 1, 6 times 2. All right. Moving on to our application problem. The picture shows an intersection in Stony Brook Village, and it is a little difficult to read. The town wants to construct 2 new roads, Elm Street and King Street. So these are the names of the 2 new roads. Elm Street will intersect. So what does intersect mean? Cross the Lower Sheep Pasture Road. So here is Lower Sheep Pasture Road. Run parallel. It has to intersect here and run parallel to Main Street. So what does parallel mean? Remember, parallel lines. And be perpendicular to Stony Brook Road. So now sketch Elm Street. Show me where you're going to put your street. Show me what that new street's going to look like, and then check back. All right. Did you create a road that intersects a Lower Sheep Pasture and runs parallel to Main Street and is perpendicular to Stony Brook Road? Remember, perpendicular means crosses at a right angle or forms a right angle. All right, next part of our application problem, King Street will be perpendicular to Main Street and begin at the intersection of Upper Sheep Pasture Road and East Main Street. Sketch King Street and check back. All right. Hopefully you were able to identify that this is King Street will be perpendicular to Main Street and begin at the intersection of Upper Sheep Road, Pasture Road, and East Main Street. All right. Moving on to our concept development, I'm going to stop the video and I'm going to restart it for part 2 of Module 6, Lesson 2.